Hi guys, Shouvik here. Welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes, so today we have this problem divisible and non-divisible sums difference. So this problem tagged as an easy, but I feel so it's an easy based on the current constant. But these problems can be like come up to in medium difficulty also, like where actually the constant is going to be a more strict side and you have to think kind of like more optimized versions, not the brute. But for the current easy tagged versions of it, you can submit a direct brute and it is going to give you a AC for sure. But as we are doing for all our videos, we will try to solve these problems to the best of it, like the most optimal versions we will try to solve it out. Correct. So yeah, so on this problem statement they have given positive integers n and m, and they have defined two integers as follows. What are those? Num1, the sum of all the integers in the range from 1 to n, both inclusive, that are not divisible by m. So num1 is the sum of all the integers in the range of 1 to n, inclusive both, that are not divisible by m. And num2 is the exact same lines they have written, but here which are divisible by n. And what we have to return num1 minus num2. I think the problem is very straightforward. There is no super magic exist on this problem statement. So here in this example test case, you can see our n is given as 10. So that means we have to consider the range from 1 to 10, and on them on 1 to 10 range, how many are basically divisible by 3. So that their sum is going to be num2, and those are not divisible, their sum are going to be num1. So here you can see, like in the range of 1 to 10, that are not divisible by 3 are 1, 2, 4, 5, 7, 8, 10, and their sum is 37. And in the range of 1 to 10, that are divisible by 3 are 3, 6, 9, and the num2, the sum of those are 18. So 37 minus 18 is 19. So we have to return 19. Here also, like num is like in the range of 1 to 5 and m is 6. So here you can see, like 1 to 5 that are not divisible are all. So num1 is 15, and on num2 we don't have any ones that can devise that can be divisible by 6. In the range of 1 to 5 there is no one. So on num2 the sum is 0. So we return 15 minus 0. So as 15 is the answer. On this example test case, like n as 5 and m as 1. So in this example test, the integers in the range of 1 to 5 again, so we have considered, and that are not divisible by 1 are empty, because all numbers are divisible by 1. So num1 in the sum is 0. And what are the divisible group? The divisible group are all. So their sum is 15. So 0 minus 15, the answer is minus 15. So we return minus 15. So that's it, guys. Like the problems is altogether very simple, and on example test case also you should get a very strong grade. Now you can see your constant are in the range of 1000, which is iterable. So the brute is how. So tell me, guys, tell me what should be our brute should look like. So our brute, what happens? It started going. Okay? So we definitely have a num1 and num2. Both we can start with 0 and 0. So we can write for each in range, tell me, 1 to n plus 1, because n plus 1 is not going to, n plus 1 is exclusive. So the iterations is go to 1 to n only. And now what we have to check, tell me what we have to check, guys. If my this particular number is not divisible by whom? By m, right? If it is not divisible, so if there is something exists, if it is not divisible, then on which I have to add? I have to add it to my num1. And what is its contributions? Num1 plus equals to each. Else, that means it's divised. So where I am going to add? I think there is some serious issue to my OneNote for sure. It's not coming as an options. I think this OneNote has crashed. Let me just restart it. Yes, so where we are. Yes, so now if it is not divisible, if it is not divisible, then I am going to add it. What is the contributions? I am going to add it this each. On else block, what is the additions? What is the additions contributions? I can add on num2, I can add plus equals to each. That's it. No, that's it. Yes. Finally I can return num1. Finally I can return num1 minus num2. Yes, this will definitely work. This brute will definitely work, because, and what is the time complexity? So only one for loop we are iterating, so that is for sure big O of n. The time complexity. So the time complexity on this approach is big O of n, And on space complexity, do you see guys we are any space altogether? No, 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 all are variables. So the space complexity is big of 1. Yes, so that is the brute algo that you can write for sure for this particular problems, and you can make yourself happy by seeing and accept it. But we are not going to solve it with big of n time, big of n time. So there is a chance of optimizations for sure. Yes. So tell me guys, tell me now actually the intuitions is starting. So how actually my num1 minus num2 is actually formatting? My num1 is actually nothing but if I have the total sum of all the numbers from 1 to n, if let's suppose I have a total sum. So these are some segments, no? So these are some segments of my total sum only. So my num1 plus num2 is bound to be my total sum, right? Num1 are the sum of the numbers which are not divisible. Num2 is the group some group which are divisible. So my total sum should be my num1 plus num2. So what actually the total sum then? So the total sum is nothing but sum of the numbers from 1 to n. Yes, I can write it for sure. And is it very easy to find it out? Isn't it very easy to find it out? Yes, Shouvik, it is very easy. So what is the formula? N into n plus 1 by 2. So I got my total sum. Yes. So now there are few cases. Now there are few cases. If you observed the example test case also, then also you can get it. So if let's suppose my aim is lying altogether outside some places here. So let's suppose my aim is pointing from 1 to n greater than boundary. So not this. So this. So my aim is basically more than my 1 to n greater than boundary. So is there anyone who can divide, who actually divisible? Is there anyone in the divisible group then? So all numbers from 1 to n, all are lesser than my m. Yes, if that is so. So in this group, do we have any candidate who is in divisible group? Is there anyone? Very straightforward mathematics here. Very straightforward mathematics. Do we have any guys who are divisible? Yes, very straightforward no. So can I say then my num2 in that case is 0, because we don't have any candidate who are actually divisible. We don't have any candidate altogether. So num2 is for sure 0. So then my num1 minus num2 actually boils down to num1 only. So num1 is actually the group which are not divisible. So in this case we are basically all the numbers from 1 to n are going to categorize to num1 only. So the divisible group only. And what is their sum? So num1 on that case is basically sum of 1 to n. Yes. Now on that case my num1 is actually boiled down to sum of 1 to n, and my answer is also equivalent to this. So on that case I can directly return my total sum. I can directly return my total sum. Yes, agree guys? Agree? Definitely agree. So that is one case for sure. So I can write it as case 1. Yes. Now we can jump on case 2. So how should be our case 2 should be looks like? So on case 2, you guys have seen, right? So all are categorized in num2. So on first category, all are categorized in num1. So in category 2, is it possible to all are categorized in num2? Yes. If my aim is 1, right? If my aim is 1, then my num1 is actually the not divisible pair, and we all know one can divide any number, right? One can divide any number. Yes. So if my aim is 1, so what is the case 2? If my aim is equals to 1, so that means on num1 we don't have any candidate, because num1 are not divisible candidates, so it is bound to be empty. And on num2 we have all the candidates. And what is the candidate sum then? From 1 to n, sum of 1 to n. So that is nothing but my total sum. And what is the formula of total sum? Is nothing but n into n plus 1 by 2. So that we will initially store on my total sum to be n into n plus 1 by 2, because we definitely need this on any case for sure. So we can return now my total sum as it is. We can return my total sum as it is or not. So num1 minus num2. So my num1 is 0 and num2 is total sum. So we have to return negative of total sum. No, negative of total sum. Yes, Shouvik, you are absolutely correct. So we can return negative of total sum. On above case we have returned total sum. On this example test case we have returned total sum. On this case we are returning negative of total sum. What we are returning? Negative of total sum. Now, actually the problematic case. Case 3. So where m is lying within the range of 1 to n. So now actually the case. Now one actual case. So here my m is lying within the boundary of 1 to n. 1 to n. So then can you guys point me? Can you guys point me one things? Can you guys point me one things? Then what are my divisible pairs? What are my divisible pairs? It's nothing but m. Then what is the next one? 2m. Then what is the next one? 3m. What is the next one? 4m. Like this we have dot many, and the last one should be, let's suppose, xm. X can be anything, any multiplier of m, but it should be in the range of within n. So we are looking for some m. So x into m should be within range of n. So what is the x factor? Then what is the x factor? So how many terms we have at? So it is nothing but n divided by m. Right? Very simple math. If x into m less than equals to n, then x equals to, I can write it n divided by m, or I can take a like modular in integer division. So that is basically stands for integer divisions. So my x is nothing but, how many terms we have in this range is nothing but n double divided by m. So that means the modular divisions. So not modular divisions, the exact integer. So that many terms we have had. Agree? Totally agreeing, guys. So now, can I put some things here? I just saw my m are going from m, then 2m, then 3m, like this. We have this series going to xm. So that is nothing but an AP series. Yes, that is nothing but an AP series having common difference d as equals to m, and what is the start point of it? It is also m. The start and common difference are both are m. And how many terms we have at on this? How many n? N is the number of terms. N is, or I can say it's nth term. How many terms within the range of 1 to n it is holding? It's nothing but n double divided by m. That we just saw. So now, can we put some formula here? Can I put some AP series summation formula here? So it is nothing but they are summations. Like this, we have summations all together. So now, if you can Google it, or you have done some mathematics on class 11 standard, then you should be aware of this. So the formula is the sum of the n terms of an AP series is n by 2 into 2a plus n minus 1 into d. So if I can write it, what it is? Tell me, guys. N by 2 into 2a plus n minus 1 into d. Yes, I can write it for sure. So now if I can replace the variables to my specific variables here, so n is going to be replaced with nth term, and nth term we have already defined. A is going to replace by m, we have already discussed. For our case, the start, a is basically the start of the AP series. For our case, it's a only, and n again is the nth term. And d is also m. The difference between them. So now if I can redesign my formula, so my formula becomes nth term by 2 into 2 into m plus nth term minus 1 into m. Yes, absolutely agreeing, guys. All are agreeing. You guys are all agreeing. Yes. So that is the sum. So now I got my num2. So that is the num2 for sure. I am able to calculate my num2 in big of 1, just in formula. And I have my total sum. Total sum is nothing but n into n plus 1 by 2. Yes. And we have already discussed my total sum. Is nothing but my num1. The sum of this plus num2. Yes, so I have my total sum in hand. I have my num2 in hand. So what we are looking for? We are looking for this num1. Yes, we are looking for that only. So more specifically, so my num1 is nothing but total sum minus num2. Yes, till now everything is clear. We are doing just standard mathematics. So my num1 we have defined, and what actually we have to calculate? We have to calculate num1 minus num2. So that actually we have to calculate. These things we have to calculate. Now, if I am going to put it in the formula, my num1 is actually total sum minus num2. If I can put it total sum minus num2, total sum minus num2, and this num2 is as it is, that is minus num2. So the formula becomes total sum. Yes, you guys are seeing, no? Total sum minus 2 num2, total sum into 2 num2. Yes, yes, we can put it like this, and so that is our final formula. So that we can return. So we have ready to our total sum calculations. We have calculated our num2. So can we then return it with just putting it formula total sum minus 2 into num2? We can do everything's in big of 1. Everything's in big of 1. So there is a slight optimizations I did. So on num2, if I can going to put the formula, it's look like something like, so there was an n by 2 factor, no? So on this formula, no? So that is our total sum for num2 formula. That is our num2 formula. So here you can see there is a 2 factor, divide 2 factor is there, and on the final formula, we have a 2 multiplicants to it, there is a 2 multiplicand. So if I can again write it here, that can be like, you guys can get it easily. So 2 into 2, there is an n by 2, right? So in nth term, we can write it nth term by 2. So I'm writing the formula for num2 only that we have defined. So 2 into m plus nth term minus 1, right? Nth term minus 1 into m, right? So that is the formula. So here you can see this 2 is going to get cancelled. This 2 is going to get cancelled. So we can just calculate. We can just calculate our total sum is as it is. Our total sum should be as it is. What is our total sum? Total sum should be as it is, n into n plus 1 by 2. And this formula, so we can do a minus of this formula. We don't need to just divide it. So this formula becomes a little bit simpler, and it becomes my nth term. Sorry guys, there is an issue for sure to my OneNote. Nth term into there is some factors. What are those? 2 into m plus nth term, the same things that we have wrote, nth term minus 1 into, so that is nth term minus 1 into m into, so our d is nothing but our m. Yes, the problem is this only. So these things we just need to calculate, and we can return. Yes, we can do. So now we can go to the code iterations. So here you guys see the beauty, right? So we are doing everything in big of 1 only. So here you can see our total sum we have calculated, n into n plus 1 by 2, the formula that we have just saw. If now my m is equals to 1, then we should return total sum into of minus 1, because my num1 is become empty and my num2 have everyone. My num2 would have everyone, because if m is 1, then 1 can divide all. That case, if my m is altogether greater than n, so that means we are not going to get anyone to be divisible group, which can be divisible by m. So because all are smaller than my m, so then on that case we can directly return my total sum. If that is not the case, then we have to define our nth term is n integer divisions of m. Yes. Now AP sum formula we have applied, nth term into 2 into m plus nth term minus 1 into m, that we are repeatedly seeing on the video, and we have ignored the by 2 factor, because here we know there is a 2 into factors is going to be incorporated. Total sum minus of 2 into AP sum, and that 2 and this 2 is going to be cancelled, and so we can just return total sum minus this formula entirely, and we have stored it in AP sum, and so total sum minus AP sum. Yes, that's it altogether, this particular problems. And you can see like it is bound to be like 100% faster than all over the submissions, and it is so. So on space time complexity is bound to be of big of 1 only, and on space perspective also it is, tell me, it is also big of 1, because all are variables we are using. So I'm just writing, just need to, as we are following this from all the videos, that purpose I am writing, but I guess you guys have already guessed it in the OneNote explanations part only. So on space complexity also big of 1. Yes. So, and we all know that is the most optimized solutions we can achieve for any problems all over the world exist. TC is big of 1 and space is big of 1. That is bound to be the most optimized versions for any problems all over the world, and it is proof, and it is definitely for this problem also. Yes. And yes guys, so we have solved it like not on the brute which they are looking for their easy versions, we are able to solve it in the most optimized versions of it, which is itself a medium problem for sure. Maybe on tomorrow we will get its medium versions. By increasing, they will increase the constant from 1000 to 10 raised to the power 9, where you can't do a iterations altogether, and you will going to get a TLE. If you are trying to submit the brute, it is going to give you a TLE, because we have the limit, we can iterate only of 10 raised to the power 8 only. So on that case, this particular gem is going to help you to get an AC. But we have solved it with the most optimized time and space, so you don't have to worry. And if you guys are able to understand till this point, so I guess you guys are already doing, please do subscribe to our channel. Please share the videos to your friends circle who are also preparing for top product based company and brushing up their DSS skills. And please turn on the notification so that when we are going to live to our next video, you will get the notification as soon as possible. So that's it, guys. That's it for today. Let's meet tomorrow with another beautiful question. Bye, guys. Bye.